the corners. Okay, good. Okay, so the medial and lateral, so it would be named, this region would be the medial or lateral canthus. The nictitating membrane, which is the third eyelid, good. Sclera is the white of the eye that you can, well, it is the white of the eye. You can see it as the white of the eye, anterior, but the sclera goes all the way around. It goes all the way around the whole eyeball, and it's very tough, fibrous connective tissue, and okay. In class, we'll see there's 3 wrappings or 3 tunics to the eye. There's an outer one, and a middle one, and then an inner one. So we'll be talking about all 3 of those, but it's the 3 parts to a circle that are going in. The sclera is part of the outermost. Here, I'll show you on this one that's cut open. Might as well do it now. So the sclera is this whole outer white part. This is all just connective tissue and fat, and there's a muscle there and so on. But the sclera is this outermost white part. It's fibrous connective tissue, really, really tough. You can see how thick it is. Okay? Then the, okay, so that's the sclera. So when you look at each other, you can see the white of the eye, that's the sclera. Okay? The iris is obviously the colored part. The limbus is the dark circle that you can see between your sclera and your iris. Michelle has got an awesome limbus. Gaze into one another's eyes and look at your limbus. Okay, mine is hard to see because my eyes are really dark. Kara's is hard to see. The rest of you have pretty good limbuses. Okay, so there you go. So that's just it gives kind of an exotic look to the eye. Limbus is neat. And then, of course, the pupil is the hole through which the light passes in the center of the eye. Okay, the undissected eye. Okay, the extrinsic eye muscles, we'll talk about those in class, but there are 6 of them that are attached to the outer part of the eye, and they're what help the eye to move. Okay, extrinsic on the outside. So the sclera, okay, here. The cornea is the transparent anterior part that the light passes through. So the why is this not transparent? Because it's dead, it's preserved, it's, yeah. But on a living animal, of course, this would be your cornea. So here's your limbus right here between the sclera and the cornea. On a dissected eye, here is the cornea here. So notice how the cornea kind of bulges out a little bit. That's significant, and we'll talk about this more when we do it in lecture.
Is that so that it stays kind of frontal?
Yeah.
Or so your eye doesn't roll around completely? And it's
it won't, because of the muscles and the tissue that's holding it in place. So it couldn't anyways. Yeah. But it contains fluid, and so it's going to have fluid in here, and that's what we're looking at. So the cornea is the anterior part. The sclera is the part that goes around all the way around the whole rest of the eye. Both of those are part of the outer fibrous tunic. What else? Oh, on the undissected eye, so you can see a lot of these muscles and tissues holding it in place here. There would be the optic nerve coming out the back. But unless it's really obvious on the eye that I'm using, I wouldn't ask it. It's going to come up right there. But it's not, you can't see it real well, So mostly I'm interested in the sagittal section of the eye that we're going to look at. So again, the cornea is the anterior part. For this test, I'm going to ask the basic structures, okay? So like the cornea, the sclera, okay? The anterior and posterior chambers, I have to do it with a picture of the eye, and I don't want to do it now. We'll do it in class, so that won't be part of it. But you're videoing this now, so you might as well know. The anterior chamber between the cornea and the iris, there's the iris, and then the posterior chamber between the iris and the lens, which would sit there. Okay. So this is the lens, okay? Cornea, iris, lens, that sort of thing is what I'm going to ask on test 1. Okay, so the iris, so name this hole pupil. Okay, that's the pupil. So the pupil isn't a structure, it's a hole. Name this opening is the pupil. Okay. Okay, so I said there's 3 tunics, 3 sort of layers to the eyeball. The outer part is the cornea and the sclera. The next part, the middle layer, so-called, is called the vascular tunic. And it consists of the iris in front, and then this ring here, called the ciliary body. It's kind of a thickened, and you can see how kind of serrated it looks. It's got a whole bunch of little muscles in it. And those little muscles and ligaments hold the lens in place and also change so that the ligaments, the suspensory ligaments, are going to hold the lens in place all the way around. Okay? And the muscles in here, they're smooth muscles, and they change the shape of the lens for distance vision or for close-up vision. So the ciliary body is really important that way. Get rid of the lens, okay? And notice that it's dark. All of this is dark, it's pigmented tissue, continues around the whole back of the eye as a structure called the choroid. So the choroid sits right up against the sclera. Then the third layer of the eye is the neural tunic, which contains your nerves. Common name for that is the retina. The retina. The retina is the part of the eye that contains the rods and cones, which are your photoreceptors. So we'll do all of this in class again, but this is where this is. It's this beigeish tissue. Beigeish? Write that out, please. So the choroid here. So the tunics, the cornea, the sclera. What did I just say? The cornea. Did I say cornea? Mm-hmm. Good. Cornea, the sclera, the iris, the ciliary body, the choroid is this black tissue here, and the retina is the part that you actually use to see with. That contains your photoreceptors. Okay, then this whole, so we had an anterior chamber and a posterior chamber. It can be deceiving. That's kind of hard. The posterior chamber is actually in the front part of the eye, which is really annoying. It's not my fault. I didn't name it that. Okay? The actual big, huge chamber back here, which you would think should be called the posterior chamber, is called the vitreous chamber. And it's filled with a fluid called vitreous humor, or vitreous fluid. Okay? And you are born with a given amount of vitreous humor, and that's it. You're done. If you lose that, you're blind. Your anterior chamber, and let's say the whole front part of the eye, is filled with something called aqueous humor. And again, we'll do this in class. So if you have an eye injury where the cornea has been punctured or something, and you have just a watery fluid running out of the eye, it's bad, but it's fixable because your body is always replacing that aqueous humor. That's another role of the ciliary body, is to secrete aqueous humor, and it's constantly doing that. So that's replaceable. You can fix the cornea, patch the eye up, and it will replace its aqueous humor. And do you know what an increased amount of aqueous humor is called in the eye? That's glaucoma. No, cataracts. Cataracts is a lens issue. You get cloudiness of the lens, because that's also normally clear. This is cataracts. Okay, actually it's preserved, but whatever. But glaucoma is an increase in the fluid in the front part of the eye here. Okay.
We do like the
tonometry. Yes. Yeah.
We do that to a lot of bugs.
Yeah, yes, because they're prone to that. We'll talk all about the details of that in class. So the back part of the chamber here, though, is the vitreous humor, and it's jelly. If you have eye damage with jelly running down, that's it. You're done, or it's done, or whatever. The other fun, really cool part that I want to show you is you can just barely start to see it on this eye here. You need to get a good video of this, so I'll turn it around so you can see it. Here, see that colored part there? I'm lifting the retina up, and you can see this. It looks like mother of pearl, okay? That is called the tapetum lucidum. It is part of the choroid. On this eye, I took off the retina so that you could see the tapetum lucidum of the choroid. So the choroid is mostly dark, but you have this part here. What do you imagine would happen if you shone a light on that? It'd be shiny. It's reflective. When you take a picture of somebody and you point the camera straight at their eyes, what happens when the picture's developed? Red eye. Humans don't have a tapetum lucidum. When you see a deer in the headlights at night, what color are their eyes? Yellow, green. Cats, you take a picture of your dog or your cat, they have green eyes, not red eyes, because they have a tapetum lucidum. And what the function of that is exactly what you think, is that it reflects light on low light conditions. We don't have one, which is why we don't see well in the dark. Cool, eh? Yeah. But tapetum lucidum, it's a reflective. It increases vision in low light situations. I will not ask you functions of any of these things on this test. Okay. And here, the other neat thing on this eye, I took the retina off, but notice how I couldn't take it all off. The rods and the cones in the retina, all the way around, okay, so all of these are photoreceptors in this retinal tissue. All those rods and the cones are, the dendrites are photosensitive on the endings, and they'll depolarize in response to light changes. Some are more sensitive than others, and then they'll run all the way, all of these dendrites will run all the way back out of the eye to form the optic nerve. The dendrites form the optic nerve. The optic nerve is a sensory nerve, and it runs to the brain, and that's where they're interpreted. So these dendrites are really long. They're sensory dendrites. They run. Do you know where your vision center in your brain is? You have any idea where approximately? It's in the back of your brain. I put the brain away. No, I didn't. Yes, I did. Sorry. It's in the occipital lobe of the brain is where the visual center is. So that's why on the brain, if you remember, the optic nerves coming in, they cross, and the optic tracts go back. The optic tracts run all the way to the back of the brain, the occipital lobe. And that's why if you get a injury to the back of your head, one of the big concerns is, are you going to go blind or not? What are you talking about? My eyes are in the front. I'm fine. But if you damage the visual center in the occipital lobe, you can go blind, even though there's nothing wrong with your eyes. I learned about that when I was a kid watching Lassie, because a kid fell down. You're not taking this, are you? Kid fell down, hit the back of his head, and went blind. Wow, that freaked me out. It's very traumatic. Anyways, what I wanted to point out on this one here, I get sidetracked, is that here is what's left of the retina, and I couldn't pull it all off because this here is the optic disc where the all of the dendrites are coming together to form the optic nerve, which comes out the back right here. There's the optic nerve there. So if I put the probe out, it would come out the middle of this here. So, and we'll review all of this again when we do it in class. So for this test, there's not much on, but I want you to know cornea, sclera, iris, pupil, retina, the basic parts that you should have an idea of. Okay? Good.